Yeah, okay. Well, thanks so much to our first two speakers. Because of our schedule shifting, we actually have a few minutes right now before coffee, so I'm going to ask Carly and Caroline to come back up for just a few minutes and we can take a few questions if that's all right. Calling an audible for those who know American football. So, please, yeah. I think I'll do the mic thing.
Your last remark on the missions that are foreseen but do not use this new technology was referred to Europa Clipper and its problem with chips that apparently are not as radiation hard as they should be.
So your question is the aversion to using technology related, for instance, to the MOSFET problems that we're experiencing now on Europa Clipper?
Yeah.
Yeah, so of course. People want to minimize risk on expensive missions. It's always a trade between what's going to be causing problems that's going to exceed cost and schedule that might cause them to be canceled versus the capability provided by that new technology. And so you might argue that there is a culture that focuses more on the risk and maybe less on the opportunity. And really it's a balance. So how do we make sure that we keep opportunity space in the forefront of mission designers' minds? Does that help?
Yes, since it was very astonishing reading that such an important flagship mission may be delayed because of this problem. Yeah. And talking about problems, if I may, you did not touch the moon and so the Viper's mission. And I read yesterday that it's being cancelled.
Yeah.
That's another risk opportunity situation, since a mission was deemed to be too risky, and NASA prefer to lose I don't know how many hundred millions instead to take the risk.
Yeah, so that's very sad. Nobody likes seeing missions canceled, and I'm sure that the reasons were complex, and there's nobody that took any pleasure out of that. I can't speak to the specific reasons for that cancellation.
I would just have a counterpoint as well. I'm on Europa Clipper, and so the MOSFET issue touches my research quite deeply. And I just think it's brilliant that we're having this conversation, right? That NASA puts it out there, that there's a problem, and that they're trying to do everything to resolve it. And we know about it whilst it's on the Earth. We can fix it, right? Isn't that great? I think it could have been, you could imagine a scenario whereby it was hidden and we launched, and then we got there and things failed. But no, instead, we're doing it. We're doing the hard thing of fixing the problem and talking about the problem and trying to make this mission as successful as it can be. And I think actually that I've kind of got the counterpoint. Like, if it needs to be delayed, it needs to be delayed. But let's do it right. We don't go to the outer solar system very much. We should go more. When we go there, it is important to get it right, because it does take a long time and it is expensive. Like, I'm really looking forward to Europa Clipper, and I think it's going to be great because we're fixing it.
Hi, Carolyn.
Hi.
With regard to Uranus orbiter and probe,
Yeah.
The Outer Planets community is really excited about this mission. As you pointed out, the Decadal Survey studied a mission that would launch in 2031, which is coming right up. We don't have a new start for it yet, so it's going to be hard to actually launch in 2031, but sooner is better. Ideally, we'd like to get there by equinox in 2049, 2050, so that we have similar lighting conditions to what we had during the Voyager flyby. We can compare what's going on. But regardless, we want to do the mission. And we, in the Outer Planets community, are really interested in the possibility of aero capture, I would say. That's been a big topic of discussion, and so I'm really happy to hear that you want to do tests of that technology. I guess using a small sat at Earth. And I'm wondering if you can say a little bit more about that.
Sure.
And when those tests are going to happen. Are they going to happen for sure?
Yeah.
Because
Yeah.
we're in favor of that.
Yeah. So first, let me say that the timing of getting, to Uranus matters. And one thing I forgot to mention, that one of the benefits of using particularly nuclear propulsion to get there is that you reduce your reliance on having all the orbital mechanics line up, right? So part of the trick, the origami of figuring out when to launch a Uranus probe is where the other planets are so we can do gravity assists. And you can eliminate that with nuclear propulsion, right? So, you can still use gravity assists, but that really simplifies your flexibility of launch dates. As far as an aero capture mission, I've been working with NASA's Space Technology Mission Directorate because it seems like a very natural place for them to do, and they are very cooperative, and we've been having great discussions about it. They understand exactly the perspective of the Science Mission Directorate. We involved them in the study. We took their input. They are working through their budget process now. I don't know how the budget's going to go, but if they decide to fund it, then it could start as early as a year or two. But I don't know because it's all budget dependent. It is absolutely on their radar, and so I'm hopeful that it will happen, but I don't have control over that. Thanks for the question.
Thank you very much for the two wonderful talks. They were really inspiring. How does NASA consider using the new capability coming out of SpaceX for the Starship? How is that going to change the way? Do we really have to wait 15 years to get to Uranus, or how will NASA use Starship?
The trouble is you have to slow down, right? So I led a concept study where we tried to put an orbiter at Pluto, and as fast as you want to accelerate, but then at some point you have to decelerate. And so it does help. It depends on the mission. Starship is going to revolutionize, I think, our access to space. I completely agree with that. If you want to go into orbit, you've still got the curve. So if you launch quicker, that's nice, but the faster you go, the more you have to slow down. So there's a trade there. Amanda. There you go. Starship plus aero capture is the way forward. And I was really excited to hear the concept study that was going to be done for aero capture, because I think it is, as someone that proposes missions, new technology is fantastic, but there's this risk trade, and it's really nice to have that risk reduced in a proven way. Are we going to coffee now?
One more.
We've got one more. Okay.
Then we're gonna...
Last one before coffee. So thanks for the presentations, very inspiring indeed. So you both mentioned that new missions, we explore new parameter spaces, and there's always these unknown unknowns that we find. But then on the other hand, this is always hard to, on the one hand, convince funding agencies to do a fishing expedition for unknown unknowns, to be devil's advocate here, but also to derive science requirements for things and mission requirements for things that you don't know yet or can't anticipate yet. So can you comment a bit on the strategies or how to approach that problem on the funding side, but also on the tech development side?
Yeah, it is tricky, right? So especially when you're going to a world that we knew nothing about. Like when we were flying past Pluto, we had two trajectories because we didn't even know what the space around Pluto looked like. If there was a debris field close to Pluto, we had a complete setup for flying a different trajectory that was further from Pluto. And so you want to take the best tools that you can, your Swiss Army knife of tools. You want to have the best technology that is available to you as you fly. But you're right, you can't build science requirements about the unknown unknowns, right? You go to solve a question, and then you serendipitously see things as you go. But we're people and we want to explore, and I think no instrument team has ever developed an instrument, with their tight set of requirements and then not, looked at other stuff, right? Because we're people, and so I think you go to solve a question, and we see what we see. But
I think that was a good answer.
Thanks to Carly and Carolyn for that. Great talks, and
Thank you.
sorry to those who still had questions, but there'll be another time after the next bunch of talks for Q&A during the panel discussion, so hold on to those questions, and we're going to break now for coffee. Thanks.